back to Eric's place. I am the Purple Professor, Albert Herkin Birkin Birkin Huffer. And I want to show you something today that has to be in my top 1 or 2 list of favorite demonstrations to do. This is a water jug. Holds water, normally. We're going to do something else with it today. And we're calling it the Whoosh Jug. Sometimes we call it Darcy Blows. Well, you'll see in a moment. It's going to blow. So what I want to do is introduce you to the idea of air pressure. You know what air pressure is. Perhaps you've heard us talk about this before. If we had 1 square inch column of air from here to where the air stops, that column of air would weigh 15 pounds at sea level. A little less as you get higher up in the mountains. Now, air pressure, that's just 1 little column of air. And we've got all these columns all pushing down. They weigh so much and it should be so heavy. But here's the difference. Here's the solution. The air is pushing up on us as well. It's pushing in, it's pushing out, it's pushing around. It's just all everywhere. Air pressure. And air pressure has this big, overwhelming desire to be equilibrium. So you want to have the same amount of air inside the air pressure and the same amount of air pressure on the outside. So you got it pushing out, pushing in, and everything is equal, so everything is happy. Now, if you go up a mountain, or if you take off in a big plane, or a little plane, if you're taking off and going high fast, your ears will pop. So today, we're going to put air pressure to work for us. We're going to let air pressure be the force behind crushing this jug, because I can squeeze it like that and it still keeps its shape. But if we can figure out a way to increase the air pressure on the outside, decrease it on the inside. In other words, if we can have less pressure on the inside pushing out than we do on the outside pushing in, we can let air pressure mash it up for us. So what we need to do, of course, is to get a little fuel in here. So we have a little bit of fuel. We put that in there. We're going to shake it around. Don't know if we have enough. I think we do, but we've got a little bit more setting here. Why not use it? All right. Oh, there's a few more drips and a few more drops. All right. So as we're getting it in here, we're taking our fuel and we're turning it into a vapor. And as it gets into that vapor, it fills the jug. And this is what will make the jug go whoosh as soon as we add a heat source. All right. So we've got it going around in there. Got it all shaken up. Let's see if we have any extra. Drain it out just a little bit. There's not very much, not a lot of extra. That's good. All right, so we have that out. And I think it's just about ready to go whoosh. And then we'll put the air pressure to work for us. All right, so we'll have the jug up here. I'm going to run around and turn off the lights. And when I get those lights off, I'll come back and we'll make the jug go whoosh. Are you ready for this? That's one of my favorite. You stay tuned. I'll be right back. I'm going to step around here. And we've got one more light to get off. And we can turn that one off now too. And we're in the dark. Oh, there's a little bit there. All right, so here we go. Time for the whoosh jug. You watch carefully because it will happen fast. If it happens at all, it's going to happen fast. I'll give you that light. You can see that. You can see me in the glow. Okay, here we go. Time to whoosh. Okay, let's get some light. Did you see that? Did you see that whoosh? All right, now can you see the jug? We've put air pressure to work for us, and you see that I've capped it off on the top. This is what happens. We have raised the temperature inside very quickly, and that means that there is less air pressure on the inside. That less air pressure on the inside, we cap it off, because if we had left our hand off, then the air would have equalized very quickly and wouldn't have crushed it. But because we cap it off so that it can't get any air in, the air pressure on the outside being greater, it smushes it in. And so that's how much it took for the air pressure to equalize. Now it's equal on the inside and the outside. Now here's what's interesting as well. I'm going to move my hand, and you watch what happens to the jug. Did you see it pop? It's popping back out. Here we go. We give it a gentle squeeze. Now it's back to almost normal. That's what happens. Because when the air pressure got less on the inside, we capped it off. Then the air pressure that was greater on the outside, just mashed it together. And then when we moved our hand, we let more air come back in, and it popped back out to normal. This is the Whoosh Jug. And hopefully you have learned something today about air pressure. So, thank you for stopping by Herc's Place. You're welcome anytime. We'll have a new experiment or a new demonstration upcoming very soon, so you stay tuned. But for now, that's all we have for today. I am the Purple Professor. This is Herc's Place, and thank you for stopping by.